I'm Anil Kumar. Let me thank all the viewers and subscribers for watching my videos and posting excellent suggestions. We regularly get very good questions from our subscribers. Here I am glad to share one with you. It is based on vectors application. The question here is, Rory, Martin and Riley are climbing a tree on their physics is fun excursion, and Riley drops his worksheet which falls onto a branch below them. Rory and Martin sit at different heights on two different branches and, holding Riley's legs at the ankles, lower him down in the gap between them so that he can reach the worksheet. Because of the way they are arranged, there is a 90-degree angle between Riley's legs. One leg makes an angle of 40 degrees between it and the vertical plane of Rory's branch. Riley's is held in equilibrium and rescues his worksheet. If Riley's mass is 80 kg, draw a vector diagram representing the forces involved in the above scenario. Calculate the force needed by Rory and Martin to hold him in equilibrium. So that's an interesting question. It will take some time to read and digest. I'd like you to pause the video, read it nicely, understand, make a diagram. So what we will do here is, we'll first make a position diagram. And from position diagram, we'll make a vector diagram and then solve it. Is that clear? So let's go through this once again. So Rory, I'll just call this as RO, Martin as MA, and Riley as RI. They are climbing a tree on their physics is excursion, and RI drops his worksheet which falls onto a branch below them. RO and MA sit at different heights on two different branches and, holding Riley's legs at ankle, lower him down in the gap between them so that he can reach the worksheet. So the situation is kind of like this. They are at different levels. So we have very less space here. So let's say this is different levels, right? So they are holding RI, right? So they are holding him, right? Kind of like this. So let's say they are holding him like this. Let us say that is the situation now. Now, we are also given that this angle formed is 90 degrees, right? So the angle at the legs is 90 degrees. That is given to us. We are given that the mass is 80 kilograms, right? So the mass is 80 kilograms, right? Now, the angle, one leg makes an angle of 40 degrees between it and the vertical plane of Rory. So let's say this is the vertical, right? So since this is a smaller angle, we'll make this as 40 and with RO, right? So 40 degrees angle between it and the vertical plane of RO. Does make sense, right? So Martin is on this side. Total is 90, so that has to be 50, correct? Draw a vector diagram representing the forces involved. So we are now talking about forces. So how is mass and force related? Well, force is equal to MA, right? So these are all vector quantities, correct? So since they are vector quantities, we just write this as MA. And mass is scalar quantity, I'm sorry for that. So it's a scalar multiple, right? So what we get here is force is equals to 80. Acceleration due to gravity is the acceleration we're just pulling it downwards, right? It is times 9.8. So that becomes the force in newtons. Is that clear? So that is how we get the force in newtons which is acting downwards. Now this is called the position diagram. We'll say these are the two forces which we need to figure out. Sometimes we refer to them as tensions. So let's say this is FRO and that is F for Martin. Now it's very simple to calculate these forces once you make a correct vector diagram, right? So what we have here is known as position diagram. So let me write down. This is position diagram. Okay. Now the vector diagram, the idea here is that we have now 80 times 9.8 and it becomes, this is meters per second square. So that becomes Newton as the force acting. So when they are at equilibrium, they are held in equilibrium, then it really means that equal and opposite force is being applied here. So when you multiply, it becomes much longer, right? So we'll represent this as a vertical line in opposite direction. Does it make sense? So that becomes the 80 times 9.8, which is 8 times 8, 64, 6, 72, and 6 is 78, 784 newtons. So this is your 784 Newton force acting upwards that keeps this system at equilibrium. So it's called equilibrate force, right? Now how do we make this? Well, what we are going to do is from here, see this vertical line? So this is going vertically upwards. We'll draw this line parallel to this. So we'll draw this. This is at 50 degrees. So as you can see here, this angle here is 50 degrees and that is FMA. Okay. Now this force is for Martin. From here we'll make the other vector, which is that one for Rory. So let me just make two arrows here, make three arrows rather. So this one is parallel and do you see that? That angle. Now, since this angle is 50, right? That is 90. This has to be 40 degrees, right? And we know that is going to be 50 degrees. We know these two forces are at right angles. Is that clear to you? So we have a right angle triangle in which we know all the angles and the hypotenuse. Correct? So it's very simple to figure out these forces now. So we have this as force due to Rory. You can actually solve this triangle to find both the forces. Clear? So let's do it. So from here we get force. Now if you look at this triangle, that becomes 90 degrees, correct? Let me just say this is 90 degrees for you. That's the hypotenuse, correct? This is the adjacent side, right? So what do we have? Force due to Martin, exerted by Martin, will be 784, this force, times cos of 50 degrees, correct? So it'll be 784 cos of 50 degrees, right? So you can calculate this using calculator, and force for Rory will be, that is the opposite side. Just solve this 90 degrees triangle. 784 sine of 50 degrees. Correct? Let's calculate these values and get our answer. 784 cos of 50 is equal to 503.94. So I'm rounding this to 504 newtons. And 784 sine of 50 degrees is 600.56. Let's write 601. Okay. Okay, so we could round this to 600. Okay, 600.6 newtons. So that is our answer, right? So we get 504, we should write 0.0 newtons, right? So I'm not getting into the accuracy of the answer, right? So we'll write 504 newtons and 600.6 newtons, right? So these are the forces involved. Now remember, in these questions, whenever physics is involved, you have to take care of the units and the number of decimal places which you should be, significant places which you should be worrying about to write your answers, correct? So that's kind of important whenever you're doing these questions. So keep that in mind. Okay. But broadly speaking, just taking vectors into consideration, this is your vector diagram. And since it's a right angle triangle, you can straight away solve the triangle knowing the hypotenuse is 784 newtons, which we just calculated as 18 to 9.8. Use cosine and sine components to get your result, right? So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.